G'day from Australia, everyone. Thanks so much for joining me for part 3 of my series on building microservices with Node.js. I want to begin with the tradition we have here in Australia. I want to start by acknowledging the traditional owners of the land from which I'm broadcasting. I'd also like to pay my respects to elders past and present. Well, welcome again, everyone. My name is Ashley Davis. I'm the author of Bootstrapping Microservices. This is my book. Please feel free to contact me anytime later. You can see my contact details on every slide. I'm going to share my slides with you in just a moment. You'll see my email. You'll see my Twitter handle, which is ashleydavis75. Best place to get in touch with me is on Twitter, really. If you missed parts 1 and parts 2 of this series, so today is part 3, you can catch up later on YouTube. I'm just going to share my screen with you. Just give me a moment, and then I can show you where on YouTube to find it. Where are we? Let me just get organized here. Okay, cool. So you should be able to see my screen now. But let me just figure out how I can look at the people who are waiting to get in, because I'll just need to kind of pause every so often just to let people in as they arrive. I think I know my way around Zoom by now, but still have trouble finding the things that I need to find. Oh, here we go. Cool. Hopefully I'm good now. Okay, so as I said, this talk is part of a 3-part series of talks. In part 1, we talked about microservices in general and why you should use them and what they're good for. I did a live demonstration of building a really simple Node.js microservice and building that into a Docker image. In talk 2, we talked about scaling up to multiple microservices in development using Docker Compose. Let me just show you where you can find these talks. You can find them on my YouTube page here. Search for the Data Wrangler. And there's heaps of videos, but if you go to playlists and if you find building microservices with Node.js, look at the playlist. You'll see parts 1 and part 2 here that you can watch. And part 3 today, I'm hoping to get that up on YouTube as soon as possible as well. So later on, you can catch up on this whole video on YouTube. So today in part 3 of the series, what I'm talking about is deploying microservices to Kubernetes using Terraform. I'm actually going to give an example of both using Terraform and using Kubectl, Kubernetes YAML. So I'm going to show you 2 ways of doing it. Before we get into the good stuff, I just want to tell you a little bit about myself. I'll keep this quick. I'm the CTO of Sortl. We have a product that helps you manage your digital assets through the magic of machine learning. I'm also the developer of Dataforge Notebook, which is like Jupyter Notebook, but for JavaScript and TypeScript. You can prototype your code with live visualizations and then later export your code to run in production. I'm also the author of 2 books with Manning. Data Wrangling with JavaScript, my first book, shows JavaScript developers that they probably don't need Python. Most of what you need for working with data in JavaScript is already available. You just need to learn how to use it. And of course, my latest book, which is Bootstrapping Microservices. So, you know, this is a practical and project-based guide to building applications with microservices using all the great tools like Docker, Kubernetes, and Terraform. I'm going to show you in the book how to build a small but complete microservices application. Start really simply by building just a single microservice, packaging it and publishing it using Docker, and then ramping up to multiple microservices and simulating a complete microservices application locally using Docker Compose, and eventually ramping up to building a Kubernetes cluster and then deploying your applications to it. So the content you'll see in the talk today and in the whole series of talk, it's very much related to the book. What I'm talking about today is more from the advanced chapters of the book, later in the book. But if you like this talk, if you like this series of talks, you can definitely find more of it in the book. Please stay until the end. I'm giving away a free copy of the book today, and I'll have a discount code for everyone else. So in part 3 of this series, we're going to go to production. I'm going to tell you more about Kubernetes and Terraform. We're going to talk a little bit about managing data in production. I want to briefly look at, as I promised in earlier talks, I want to briefly look at indirect messaging using RabbitMQ. That's a message queuing software. And I'm going to do a live demo deploying a microservice to a Kubernetes cluster that I prepared earlier. I'm even going to show you just basically the steps to go through to create your own Kubernetes cluster. So it's not as hard as you think. And I'll show you how to do that. So if you want motivation for how to use microservices or for using microservices in the first place, or you know what the benefits are of using microservices, please look at the first and second talks in this series. I'm not going to cover that again today. Let's start with this question: when should we go to production? Well, before that, like, what do I mean by production? Well, when I talk about production, what I usually mean is the place where the application is running so that it's accessible to our customers. So production is our customer-facing environment. It's the version of our application being used by our customers. Now, my answer to the question, when should we go to production? That's as early as possible. We should go to production as early as in the development lifecycle as we can. And there's a couple of reasons for this. First is because production issues are easiest to solve when the application is still small. And building an automated deployment pipeline, which is really important, that's also easiest when the application is small. And the longer you leave it, the bigger the application grows, and the more difficult it will be to actually go to production. Now, the most important reason that we should go to production early is because that's where we need our application to be so we can put it in front of our customers, right? Your application needs to be in front of customers so that you can get feedback, validate your business model, and iterate on your product. So it's vital that we go to production early, as soon as we can. And this is especially important for startups with new products that need validation. Let's understand some of the basic production needs of microservices. First up, we have the same basic needs as in development, like we discussed in the first two parts of this series. And that is communication between microservices and data management, databases and file storage for microservices. I covered direct communication in the first talk. You can find that on YouTube if you want to catch up. And today I'm going to talk a little bit more about indirect communication because I promised to do that from the earlier talks. And in the second talk, I showed you that you can easily have a database for development using Docker Compose. Please look at talk 2 on YouTube if you want to see that again. Today I want to talk a little bit more about the database. Not much really, but I want to talk about how we should implement a database in production. So what are the additional needs for running microservices in production over and above development? Well, firstly, we need a place to host our microservices. For that, I choose Kubernetes, and I'm going to tell you why soon. Today, I'm actually going to show you how you can start your own Kubernetes cluster, and I'm going to give you a live demo of how to deploy a microservice to it. Then we need deployment tools. Now, we already have Docker, of course. We've talked about that in the earlier talks in this series. I showed you in talk 1 how to build a Docker image for your Node.js microservice. To deploy to Kubernetes, though, we also need something else. We need either kubectl, kubectl, whatever you want to call it. That's the command line tool for Kubernetes that we can use to kind of deploy using YAML files. Personally, I prefer to use Terraform, which is another command line tool. We can use Terraform for a whole bunch of different things, but we can also use it for Kubernetes deployments. I'll tell you more about Terraform soon. So we actually have 2 tools that we could use to deploy microservices to Kubernetes. And today I'm going to show you how to use both, just in a live demo. Now, not only do we need the tools to deploy our application, we also need to be able to put it on automatic so that whenever we change our code, whenever we push our code, we're going to invoke our automated deployment pipeline and roll out a new version of our application, or at least a new version of a microservice in our application. We're going to be using a technique called automated continuous delivery. I'm going to show you an example soon that's going to be based on GitHub Actions. So my book uses Bitbucket pipelines, but today I'm going to show GitHub Actions, which is really cool as well. Finally, we need the ability to monitor and scale our application. Now, these final topics are quite advanced, and I'm not going to cover them in today's talk, but please feel free to ask me questions later or look in my book to learn more about these more advanced topics. Now, as promised in the earlier talks, I just want to talk a little bit about indirect communication. And this is a more advanced communication pattern between services in a distributed application. If you remember in the first talk, I talked about doing direct communications using HTTP requests. I gave a live demo of doing that, how you would do that from a Node.js microservice. Direct communication, it's really simple to implement and easy to understand, but unfortunately it results in this really tight coupling between microservices. Using message queues like RabbitMQ, on the other hand, allows for indirect communication. And that's where the communicating microservices don't have to know about each other. So that's what I use RabbitMQ for, indirect messaging between microservices. You can see it in the diagram here from my book. The message queue is acting as like a middleman between two microservices in this picture, the video streaming microservice and the history microservice. This is an example from my book, of course, so it's fairly specific. But this kind of indirect communication means we can decouple our microservices, and that makes for a more flexible and scalable application architecture. And I want to show you, I'm not going to go into too much details of this. I'm not going to give you a live demo of this, but I'm going to show you where you can find some example code that demonstrates using RabbitMQ to send messages between microservices. And let's just have a quick look at that now before I move on with the rest of the production stuff. So I've got an example on my GitHub. So look at my GitHub, Ashley Davis, Rabbit messaging example. Now there's a bunch of sub examples here. There's instructions on here on how to get it running. I'm just going to show you what this looks like in Visual Studio Code. So I'm just opening this project that I already cloned in Visual Studio Code. You can clone this for yourself from GitHub. There's a bunch of subdirectories here with various examples, like there's, emitting a message here from one microservice is only going to be handled by one other microservice. Once the other microservice has consumed it, that message will be gone from everyone's queue. So it's like a publish once, handle once scenario. Then there's a broadcast example. And so that in that, a microservice can emit a message and it can be picked up by literally every other microservice. So it's like it's broadcasting a message to all the other microservices in the application. There's a couple of other examples here, but those are the important ones: emit and broadcast. I'm not going to run this now, but if you wanted to run this, you could clone it. Just go into the emit directory like this, and then run docker compose up build. That will build it and run the whole thing. There's only 2 microservices, so it's not like it's a huge application or anything like that. Actually, I found out the other day that Docker Compose is built into Docker now. I only just realized this the other day. So you can actually literally just run Compose as a sub command of Docker, which is kind of cool that they've integrated that in Docker Compose. Now it's like an integral part of Docker. So that's really nice to know. Okay, so indirect communication, basically, we're from one microservice, we can publish a message. And instead of that message going directly to another microservice, say the history microservice, that message goes into a queue. And then when that microservice, other microservice is ready, it can pick it up. So the microservices don't know about each other. The messages are queued up, can have multiple messages queued up. So the other microservice can handle the message when it has capacity to do so. So this communication pattern, it's more complicated, obviously, than direct communication. It makes for a more complicated application, and but it gives a lot of flexibility, a lot of power. You can build some really advanced communication techniques based off this communication pattern. Cool. I'm going to move on now. I could spend a whole talk talking about communication between microservices. Please see that example. I'll just show you that again before we move on. So it's on my GitHub page, Ashley Davis, the RabbitMQ messaging example. Also, I cover this in my book in over the course of a chapter, how to use RabbitMQ, how to emit messages, how to receive messages. So please look at my book for details on how to get started with that, if this isn't enough. But this is fairly simple example code, should be fairly easy to follow. And now I want to talk about continuous delivery. Continuous delivery, it's the ability to deploy our application at any time. Like that's generally speaking what continuous delivery is, that we're always in a position to be able to publish or release a new version of our application. More specifically, continuous delivery is how we get a modern application to production. We're continuously delivering it to production. That's why the name is there. Most importantly, our delivery system, it can be fully automated, and this makes production production deployments reliable, repeatable, and efficient. Reliable because we want to minimize human mistakes. It's difficult to eliminate human error completely, but we can avoid it through automation. Repeatable because, it means we can do a deployment at any time and as frequently as we like. And it's efficient because we're reducing human labor through automation. A human doesn't need to spend time doing automation, doing deployments, but a human does need to spend time, fixing deployment mistakes if they happen, resulting from human error. So we don't want that. We want to basically reduce the amount of time that humans are spending putting our application into production, and we want to reduce the amount of time, our people are spending fixing errors, that would be caused by manual deployments. I like to say that the deployment pipeline, the automated deployment pipeline, I should say, that is the most important feature, because the deployment pipeline is how we deliver every other feature to our customer. I think automated deployment should be feature number one for your product, like the first thing that you implement. Here's another way to think about continuous delivery. It's simply a shell script that's running in the cloud automatically for you. Most often it's going to be building, testing, and deploying your application, but it can do pretty much anything really. Now, this is a massive simplification. I'm really dumbing this down, but I hope that it means that you can remember and understand what continuous delivery is. So if you remember one thing from this talk, please just remember that there's nothing scary or complicated about continuous delivery. It's just a shell script running on someone else's computer, okay? To better explain it, here's a diagram from my book. It shows an automated deployment pipeline. It's actually an example from my book. Now, you can see on the left here, there's a code repository on the development computer. And from there, we push code changes to our hosted code repository online. Now, in this diagram, it shows that is Bitbucket, which is what I use in the book for examples. But today, I'm actually going to use GitHub as my example. And the setup looks basically the same, though. There's not much difference between Bitbucket, GitHub, GitLab, and there's probably others that you could think of. So we push our code to our hosted code repository, and that triggers our automated deployment pipeline. This is where we run our deployment shell script. And in this diagram within the shell script, we're running Terraform, because that's often what I use, and I'll be giving a demo of that soon. And through Terraform code, we can not only create our entire infrastructure, so our entire Kubernetes cluster, but we can also deploy all our microservices to the cluster. Now, you can also run automated tests as part of your build pipeline here, as part of your deployment pipeline. And your tests would cause the deployment to be aborted if any problems occurred. So, if any particular test fails, the whole deployment is aborted. We don't get any new update because, obviously we don't want it because there's a problem with it. And so that's like a checkpoint on deployment that stops the deployment from happening if our automated systems detect any problems with it. Now, before we go any further, I think we should understand what Kubernetes is. So just in case you don't know, Wikipedia describes it as a container orchestration system or a container orchestration platform. That's a bit wordy, or a bit of a mouthful anyway. I want to describe it more simply than that. And let's make it real simple. Kubernetes is a platform for running microservices. Now, again, I'm using a massive simplification here. I'm really dumbing it down. And this is only partly true because Kubernetes can do so much more than this. Kubernetes can do more than just microservices. I mean, it can do services of any size, and and it's really powerful. It can do anything, basically. Another way that I like to describe Kubernetes is that it's a cloud-based operating system. Now, normally operating systems allow you to run programs on a single computer without having to care about which CPU your program is running on. We all have computers with multiple CPUs these days, right? Kubernetes allows you to run programs on a cluster of computers without really having to care about which computer they run on. So you can see here in the diagram, we have a Kubernetes cluster composed of a pool of computers. There's 4 computers or virtual machines underneath it. So they're underneath Kubernetes, but running on top of Kubernetes, we've got our microservices, we've got our containers. We don't care which computer those microservices or containers runs on. We just care that they run somewhere that has the capacity to run them. And this allows Kubernetes to really efficiently distribute a large workload over a pool of multiple computers. and it's because it's multiple computers that we call it a cluster. It's a cluster of computers. Kubernetes is open source, and it's built from the vast experience of Google. Personally, I like to think of Kubernetes as the universal computing platform because it's supported by all the major cloud vendors. Like you can run Kubernetes on Amazon, Azure, Google, DigitalOcean, and others. There are smaller vendors out there that also support Kubernetes. So you don't have to worry about vendor lock-in, and you can run pretty much any kind of application, any programming language, any technology stack. And if you aren't convinced that Kubernetes is the way to go, let me try and give you some motivation. Now, for a start, Kubernetes, it's rapidly becoming the industry standard for running microservices, or in general, the industry standard for running container-based applications. It can be really lightweight, and it doesn't take much effort to start it. I'll give you an idea of that in a moment, but you can run a managed Kubernetes cluster on as little as one virtual machine. So it can be cheap and convenient starting point for any new application. But it's also really scalable. Like Kubernetes can grow as your business grows. And currently Kubernetes out of the box supports scaling up to 5,000 computers. Can you imagine building a 5,000 computer cluster with Kubernetes? That is truly a huge amount of computing power, but out of the box, that's how many you can add to it. And you can also push it far beyond this if you're willing to customize Kubernetes. And Kubernetes is all open source, so you can go in there, you can customize it, and there are reports. I can't remember what the big numbers are. You can easily Google what's the biggest cluster with Kubernetes, but it has gone like way more than that. I think it might be like 15,000 to 20,000 computers, but don't quote me, because by the time you watch it, that record might have even been broken. Now, it's quite easy to set up a managed cluster. Obviously, it's difficult if you want to set up Kubernetes on your own hardware. If you want to set up your own physical boxes and put Kubernetes on each one of them, or even set up your own instance, your own VMs, and set up Kubernetes on each one, that's a time-consuming and difficult task. But most of the cloud providers, all the cloud providers actually offer a managed Kubernetes service where it's only a couple of clicks to create a Kubernetes cluster. And it's just so easy. I'm going to show you in a minute just how easy it is. Actually, I've also got a blog post on this. Let me just find my blog. Where did it go? Here we go. So my blog is called The Data Wrangler. It's at thedatawrangler.com. If you scroll down quite a few here, there's the quick guide to creating a Kubernetes cluster. And this shows you how to create a Kubernetes cluster using the Azure command line tools. So it's really just a couple of commands you've got to run to create a Kubernetes cluster against your Azure account. Also really easy to create a Kubernetes cluster through the Azure web portal. It's only a few clicks really to create that. Creating a managed Kubernetes cluster on AWS, unfortunately, is more complicated. But AWS also offer this tool called EKSCTL, which is a command line tool that actually makes it then quite easy to create a Kubernetes cluster on AWS. In a moment, I'm going to show you how to create a Kubernetes cluster on DigitalOcean. So it's easy to set up. You also on my YouTube channel, let me show you some other videos that you might be interested in. So I did a few months back, I did some other talks on infrastructure as code. So you can see the playlist. If you go to my YouTube channel, The Data Wrangler, go to playlists, view the full playlist for infrastructure as code. There's two parts to that. The first part actually shows you how to create a Kubernetes cluster using Terraform on Azure. And then the second one shows you how to then use Terraform to deploy microservices to that cluster. So if you're interested in learning more about making Kubernetes cluster, there's plenty of resources there. And also in my book, obviously, I cover this throughout 2 chapters using Terraform to create a Kubernetes cluster and then deploy microservices to it. So, Kubernetes has a reputation for being difficult, but that's not deserved because it's easy to create one, managed. The difficult part about Kubernetes is really getting set up for deployment and getting your continuous delivery pipeline set up. Again, my book walks you through that and makes it hopefully fairly straightforward, but that is the most difficult part. And once you have that automated delivery system, automated deployment system set up, then it just becomes, you just forget about it, right? Like every time you push code, it just becomes automatic and you kind of forget how it works. And like, it's like all good magic. It just sort of fades into the background and you take it for granted. Kubernetes also comes with a whole bunch of other really cool features, like, the ability to heal itself and restart its services, automated rollbacks of broken containers to the last working version. There's replication and load balancing for your services, automatic scaling to meet peak demand. This is the most important part. Kubernetes has an automatable API, so we can automate our deployments, and that's how we can build our automated deployment pipeline. It's because it's possible to automate deployments to Kubernetes. So that's really important. Now, the last thing is that Kubernetes, it's open source. It's got a huge number of contributors. It's got a huge community, and it's got a massive ecosystem of tools. So what this means is that there's always help when you need it. Whatever you need to do is a Google away, and there are also plenty of actual people out there who are more than willing to help you should you have trouble. Now, I've convinced you hopefully that Kubernetes is a good choice. Now I've got to really convince you that Terraform is a good choice. And Terraform is completely optional. I'll show you both ways of deploying to Kubernetes using the kubectl Kubernetes command line tool and using Terraform. But I like to use Terraform. I use it for a lot of my production projects. It's a command line tool and a programming language that allows us to do infrastructure as code. It's a declarative and human-facing programming language rather than it being procedural. So it's designed to be human readable and human writable. And the declarative nature of it is you describe what you want, not how to build it. I like Terraform more than YAML, so I'll show you a YAML file in a moment. YAML file, I just find YAML files I find a bit painful to work with, just because whenever you get the indentation wrong, which you kind of do constantly when you're coding in YAML, like it gives you a really obscure error message, and like it's just much easier to get a Terraform code file right and to have it work first time. Terraform supports creating infrastructure on all the major cloud vendors. So it's plugin based and it's extended to support Azure, Google, AWS, DigitalOcean, all the cloud vendors. I like to think of Terraform as the universal configuration language, because we can not only use it to create all of our infrastructure on the cloud, we can also use it to deploy our containers and our microservices. The other thing is Terraform is really smart as well. Like it records the state of your infrastructure so that updates to it in the future can be applied efficiently, effectively, and safely. And Terraform, again, like all these other good tools we're working with, is open source. And what that has meant really is that it's opened up to the community to create plugins that extend it for all kinds of use cases. So the reach of Terraform goes far. I'll show you some Terraform code in just a moment. In the early talks, I also promised that I wanted to talk a little bit about having a database in production. And there's just a few things I want to say about this. Firstly is the rule, one database per microservice. Now, there aren't many hard and fast rules that I follow, but this is one that I try to follow pretty much all of the time. We should only have one database per microservice. Microservices should not share databases. And that's because sharing databases between microservices, it encourages a really brittle architecture, and it's really difficult to restructure. And it's also like a scalability nightmare. Like when you actually want to scale and move your microservices around and replicate them and stuff like that, it becomes a lot more difficult. So please just remember this one rule, one database per microservice. Now, just because we have a database per microservice, it doesn't mean we have to host them all on their own database servers. That would be, not very cost effective. So we can host all our databases for all our microservices on one database server. Obviously, if we exhaust the capacity of that server, we're going to want to move on to more database servers. You do that when you have to. But By sharing a database server across multiple microservices, each one having their own database on the server, we can basically simplify the system a lot, and it also becomes a lot cheaper to run. In my book, Bootstrapping Microservices, I give an example of creating a database within the Kubernetes cluster. And that's a great approach for learning, but that's not usually what I would do in production. And I do talk about this in the book as well, the way I actually work in production. What I really do in production is I keep my database server separate to my Kubernetes cluster. You can either do that by using a managed database, which a lot of the cloud vendors have, or you can create the database yourself on a separate virtual machine. So where you install Linux and then you install the database, and it's a bit more configuration work to do that, but it's really worthwhile because having the database separate to your Kubernetes cluster, it allows you to have a stateless application. You can see how this works in the diagram here. This is a bit complicated, but this is at chapter 9 in my book. This is what the FlexTube example is looking like. So this is an example video streaming application that I use throughout my book. There's a bunch of microservices here within the Kubernetes cluster, but off to the side here, off to the right, you can see the database server with a bunch of databases in it is external to the Kubernetes cluster, which is here. And then underneath it here, you can see that there's external cloud storage services. So we can store our files in a private cloud storage container outside the cluster. So we've got basically all our storage and data facilities stored outside our cluster. What's the point of this? Why would we want to do this? Well, two reasons. First is for safety. So generally speaking, I can work on my cluster, on my production cluster, without fear of losing data. So, I could make a mistake. I could blow up the cluster. That would bring the system down. There'd be an outage, which wouldn't be great for customers. But, let's just put that aside for one moment. At least I won't lose any data. And, normally I'm not going to be doing anything risky in a production cluster anyway, right? But just say that I do need to, suddenly we have a sudden influx of customers, and I do need to scale the cluster, and I do need to make some changes there. That is a dangerous, risky change. But the worst thing that could happen is losing the data, right? So protecting customer data is number one. And if you break your cluster, you can just fix it. Outages can be fixed. Losing customer data is basically unfixable unless you've got a backup, right? Well, you should have a backup anyway, but losing customer data because you have to make a change or a tweak to your cluster is just not acceptable. So that's the first reason that I like to store data and files outside the cluster, kind of on their own virtual machines effectively. Now, the other reason to have a stateless cluster is to enable a technique called blue-green deployment. And this is a technique where you can use DNS to switch between two clusters. Let me show you that. So I'm switching between two clusters here. So you have a customer-facing cluster at the moment in the diagram. That's the blue environment. And you have your developers and your testers working on a separate cluster, which is labeled the green environment in this one. Oh, don't worry about the names blue and green. They're just arbitrary names. That's just traditionally what it's called. But you could name your clusters Rick and Morty if you want. So we've got the Rick cluster at the top and the Morty cluster at the bottom. Call your clusters whatever you want. Traditionally, they're called blue and green. And then switching between them, we switch between them with DNS. So basically what we're doing is we're making risky changes in one cluster while the customers are using the other clusters, so that we're not risking anything really. We're not risking causing any problems for our customers. And we can flip the DNS over to the new one when it's ready. And at that point, our developers and our testers can change to the alternate cluster and start working with that. So this really buffers our customers from unintended problems that we cause by making infrastructure changes. And because we have our databases outside the cluster, we don't have to do any kind of database switching over or migrations or database copies or anything like that. They're still, we're just switching application clusters. We're not switching databases. We're going to use the same database and the same file storage. That's what enables this. So that's one technique you can use there, blue-green deployment, to really kind of protect your customers from potential changes. Oh, and I'm really just talking about infrastructure changes here as well. So we can roll out safely roll out microservices. Say in this case, in the diagram that our customers are using the green environment, we can safely roll out new updates to microservices while they're using the green environment. That's not a risky change because a break to a problem with a microservice isn't going to bring down the whole system. That's one of the benefits of using microservices that we talked about in the first in the series of talks. So we can continually update microservices without having to do the switching. So this switching between clusters is really just when we want to make changes to the cluster and the infrastructure itself. Or you know, like if obviously we can use the alternate cluster as a testing ground for new features. So that's totally okay, but it doesn't stop us from updating the microservices in the version or the cluster that the customer is currently using. Okay, it's time for a bit of a demo. Hopefully the demo gods are smiling on me. I've done a bit of preparation here, so I've already got a Kubernetes cluster to work with. Before we look at that though, what I want to show you is I just want to show you how you can go about creating a Kubernetes cluster. So I've got DigitalOcean here. I like DigitalOcean because it's cheap and it's simple, and it's really good value. This is the Kubernetes clusters page. I've got a couple of clusters here that I'm using. You can see the demo cluster here is what I'm actually going to be demonstrating with today. But if I wanted to create a new cluster, I can go up to the create button here. So create a new Kubernetes cluster. Now I'm not going to actually create the cluster. I'm just going to go through the settings. You can choose a version of a cluster, choose a data center. Let's put this one in New York. If you wanted to, you could create a specific a virtual private network for this. I'm just going to use the default. Choose the capacity of your cluster here and the name of it. Let's just call this test run. So this is the name of the cluster or the pool of computers that are going to be in the cluster. You can choose the type of machine you want to have in it. There's a couple of different options there for more optimized machines. We'll just stick with the basic nodes on a shared CPU. That's probably not great for production, but it's great for testing. It's great for new applications. You can choose what plan you want to be on. If you're just going to experiment, drop down to the $10 a month plan. And the number of nodes, so the number of computers you want to power this cluster. Again, if you want to keep costs low, just put it down to one node. So this is going to be cheap. This is going to be like $10 a month to run a Kubernetes cluster. You're not going to get it that cheap on Azure, AWS, probably not on Google Cloud. I'm not sure about Google Cloud, but this is one of the cheapest ways I know to run a Kubernetes cluster in the cloud. Give the cluster a name, and then you would basically just click Create Cluster to create it. It's going to take a few minutes to create, not much at all. Okay, so, but I've got a cluster that I've already created. And this is the page for it in DigitalOcean. The most important thing you can get to here is the Kubernetes Dashboard. So if I open that in a new tab, and I'll have a look at that, what we'll see here is an empty Kubernetes cluster. So this is the dashboard. Normally, if you're running Kubernetes on one of the other cloud providers, you have to install this manually, and it's a bit of a pain to get into it. But DigitalOcean just makes it available there by default and makes it really easy to access. Now, there's a bunch of different things you can do in a Kubernetes cluster. What I'm interested in just at this moment are deployments, pods, and services down here. So a deployment is what's going to keep the replication of our application and is going to keep it alive. A pod is like a container. So a pod actually can contain multiple containers. I'll show you what that looks like in a moment. And a service is what makes our microservice or our pod or our container like accessible, both within the cluster and also outside the cluster if we choose to make it available outside the cluster. Let's just have a look at deployments to start with. There should be nothing here. Oh, we've basically got some of the built-in deployments, right? So we can just ignore those two. Yeah, so I've changed to the default namespace. So you can see in the default namespace, there are no deployments. And we're going to deploy a microservice to this in just a moment. Okay, so Where did I get to? So the first thing I want to show you is the deployment pipeline for an actual microservice that I have on GitHub. So this microservice is my user authentication microservice that I've open sourced. It's available on my GitHub, Ashley Davis, under the repo Authentic. So there's instructions here on how to get started. I've got this open already here. Okay, so I've already cloned the repo. I'm just going to open Visual Studio Code on this. Let's just close down everything that's here. Got a bunch of stuff open already. So what do we got? So the important things here for what we're talking about under the .github directory is main.yaml. So this is a configuration file for GitHub pipelines. Now this basically means that on every push to the main branch, it's going to run this automated deployment pipeline. And what this does is it builds the Docker image for Authentic. It pushes it to the Docker Hub container registry. And then it, well, that's all it does. I mean, that's part of the puzzle for microservices. Sorry, I'm just letting someone else in. So this is part of the puzzle for deploying microservices. I'll show you the other part in a moment. Now, a GitHub Actions pipeline here is composed of jobs. Now, the first job that we've got is to run tests. So this is an example of how you can integrate automated tests into your continuous delivery pipeline. Now, I'm just going to gloss over some of the stuff here because I don't really want to explain everything about how GitHub Actions works. But you can see here it's running npm test. So it's doing a bit of setup work here to get set up to ready to run the test, and then it's running tests. If this fails, if this npm test, basically, I think it's using Jest under the hood. If it fails, if it returns an exit error code of a non-zero error code, that's going to abort this this process. Now the next job is called push, and this is what builds the image and pushes it up to Docker Hub. You can see some hopefully familiar things here, like building Docker build command here to build the Docker image. I showed you how to do that in talk 1, which you can find on YouTube. And then here we're doing a Docker login. So we're doing a Docker login to our Docker Hub account, and we're getting the password here and the username we're getting from GitHub Secrets. So GitHub Secrets is a place where you can configure sensitive secret values, you know, that can then be input into your deployment pipeline. And then finally, we're pushing an image here. So this is essentially just using the Docker push command, right? So that's how we get an image up into our container registry. In this case, it's using the public Docker Hub container registry, but this could just as easily push, you know, an image for a microservice to a private container registry that we're hosting in any of the major cloud providers. And this push part. This is publishing it. This is publishing the image for the microservice so that we can then deploy it to production. So as I said, this is one part of the deployment the deployment puzzle is actually on every code push, you know, being able to build and publish an image for our microservice. Let me just show you what this looks like in GitHub Actions. So we're at the repo here on GitHub. So Ashley Davis, Authentic. If I go to the Actions tab, you can see basically all the instances for all the different versions of Authentic that have gone through the pipeline. So you can see one here that's failed. So I did something here that caused it to fail, and that's why it's got the red X. So this didn't actually result in an image going to the container registry. It failed before that happened. So any time I break a test or I break the build process or something like that, this can fail automatically. and stop the rest of the deployment from running. Now, if you want to add secrets, you can go into settings and choose secrets. You add your sensitive details in there. Cool. So now I'm going to show you how to deploy this image. So we've got this image on Docker Hub, and I can actually deploy it from there. Before we do that, let me just show you the Kubernetes dashboard again. Let me just detach this tab so I can get back to it easily. So I'll just refresh this. So we have no deployments in the Kubernetes dashboard. We have no deployments in this cluster. I'm going to deploy it right now. So in the Authentic project, if you change directory down to deployment examples, you'll find a couple of different examples there. There's a bare bones Kubernetes YAML example, and there's a Terraform example. I'll show you the Kubernetes YAML example first. Before we look at this, I'll just show you what the YAML file looks like. So let's just open up the deployment examples. So this is a YAML file for deployment to Kubernetes. We're configuring here a deployment. So this is the thing that keeps our application alive and healthy and make sure that we have, as many replicas as we want. We could have 30 copies of this microservice running on Kubernetes. Let's not do that. I'm just going to stick to one. It's saying, where we get the image from. We're plugging in a whole bunch of environment variables to configure our microservice. I think I showed you in talk number 1, a live demo of how you add an environment variable to a Node.js microservice. Well, this is where we're kind of plugging in the configuration to set up those environment variables. Now, we've got this triple hyphen here, triple dash, and that says that, this is one thing to deploy in Kubernetes. And then after that dash is another thing. And the other thing is just a service. So the service is basically what gives us a DNS name, a DNS entry for this, this microservice, so that we can then access that internally within the cluster using http://authentic. So other microservices will be able to access this one. So I'm about to deploy this file. So I've already configured, I've got kubectl. I'll show you the version if I can spell it right. So I've got, this is the Kubernetes command line tool, kubectl, Kubectl. I've heard that kubectl is the wrong way to say it, which is sometimes the way I say it, but anyway. Now I've already configured this to talk to the cluster. So that's an authentication process that I've been through. I can say get nodes. I can run all sorts of commands really to query the cluster. So this shows me that I've got one node running in my cluster. It's on version 1.20.2 of Kubernetes, which is fairly recent. So I created this demo cluster about a week ago when I was sort of practicing, what I was actually going to show you today. Now, to deploy this, I run kubectl create -f for file, and then the name of the file that I'm deploying, which is authentic.yaml. So this is now getting deployed to that cluster. And that was it. That's as long as it takes. It takes a bit longer with Terraform, unfortunately, but that's because Terraform has to think about it a bit harder. Now you can see I've come back to the dashboard here, and you can already see that I've got a deployment here. If I go to pods, you should see some pods running. So I've got one pod running. So I've got, if I had multiple replicas of this running, I could see them all here. Let's just try that actually. So I'm going to destroy this using the destroy command. Oh, sorry, the delete command. And just to show you, I'm just gonna ramp this up to like 4 copies, right? So I'm making a change to code to scale this, and I'm going to run that create command again. It might take a little bit longer to start up this time because there's actually 4 copies to be started. So you can see here we've got 4 copies of this microservice in the process of being started. So what we're doing here is we're just deploying this manually. So we're deploying an image on Docker Hub manually. So normally you wouldn't deploy manually. You want to do this in an automated fashion. But that, in this case, that's as simple as putting this kubectl create, or actually kubectl apply is a better way to do it, because then that allows you to apply ongoing changes to that. All you need to do is put that in your shell script, in your deployment shell script, or in your GitHub Actions script, however you're running your automated deployment pipeline, you just need to put this in there. Of course, before that, you need to kind of set up authentication. That's a little bit tricky, of course. I'm not showing how to do that today, but once you're set up and authenticated with your Kubernetes cluster, it's really easy to make changes to it, and you can make those changes completely unattended in an automated deployment pipeline. Now, let me just check that this is gone. So hopefully these containers here, these pods, are in process of being deleted. And there's no deployments now, so that's gone. We've cleaned up after ourselves. I'm now going to show you the Terraform example. So go back one directory and then drill down to the Terraform directory, and you can see a bunch of TF files here. So these are Terraform code files. I'm just going to show you what Terraform looks like in Visual Studio Code. So same directory here, underneath deployment examples, underneath the Terraform directory. Here's the Terraform file to deploy the authentic service. Now, there's a bunch of variables that are defined in the variables file over here. They're the kind of inputs to this, but I don't think we need to look at that now. Anyway, so basically what we've got here is we're creating a Kubernetes deployment. This is Terraform code. Again, we can change the number of replicas. We can have as many replicas of this microservice as we want. You know, we're telling it where to get the image from. It's version 1.0.9 from Docker Hub. And then this looks a little bit different to the Kubernetes YAML, but I actually think it's a better format, more forgiving, easier to code, if not easier to read. This is where we're kind of plugging in a bunch of environment variables. It's a bigger example than the YAML file because we're actually configuring it in a deeper way. And then down the end of the file here, we've got the Kubernetes service. So this again creates the service in Kubernetes that's going to make this microservice available within the cluster. I'm going to deploy this using Terraform. So I've got an older version of Terraform installed. So you can see there's a warning there. I've got 0.12.29, but it's already up to 0.15.1. I just haven't updated yet. So I'm still doing my production deployments and all my demos and stuff on this older version, but it works nicely. It works really well. Now, the first thing you have to do when you run Terraform in a directory is run Terraform Init. If you're running it locally, you only have to kind of run this init, once, and then you can deploy multiple times after that. So what this is doing is it's downloading the plugins we need, plugins for talking to DigitalOcean, plugins for talking to our Kubernetes cluster. That's good. There's a couple of warnings there about things that I need to kind of upgrade in the script. I will get to fixing that eventually. And then to actually deploy this, to run the Terraform code and deploy it, we can run Terraform apply. But what I've got to do is normally, there's a bunch of input variables that have to be configured to make this work. Mostly you can just type them in, interactively. But there's one that I just need to put on the command line here. I just want to plug in my my DigitalOcean API key from an environment variable, and the rest that I can just enter on the fly. So my cluster is called demo. My database host, this doesn't even matter because we're not going to use this microservice. I just want to kind of test that we can deploy it. We're not going to use it. So we don't even have a database. So I'm just going to say it's MongoDB running on localhost at the default port. There's not a database there. We haven't even deployed a database. So that's not even going to work. But hopefully this should be enough to deploy and see it start up. We need, because it's an authentication, see it's asking for a secret for the token authentication system. This doesn't really matter. I just for demonstration purposes, 1, 2, 3, 4. I'm not actually going to use this to authenticate a real production application. Now, so this is actually going ahead now, and it's checking what we've got in Kubernetes, and it's checking what we want to put there. So it's given us a plan. So this is the what's called the Terraform plan, which tells us what it's going to do, which is like a fair bit because it's deploying something from scratch. I'm not going to worry about reading all that. I kind of just assume that it's going to work the way I want. But now I have to confirm it. So I have to type yes. And this is actually going to go ahead, and it's actually going to deploy this to. Wow, that was quick. That was quicker than I expected. I thought Terraform was going to be a little bit slower than YAML, but it turns out it's not. So let's just check where's my cluster? There it is. So you can see now I've got a deployment running again. This time I've run the deployment using Terraform. And if we look at the pods that I've got running on this cluster, you can see I've got one. And I could scale that up. I could use Terraform to scale that. I could enable elastic scaling if I wanted to. And from there, you can actually drill down into the pod. You can have a look at it here. You can look at the logging, the logs that are coming back from this one microservice. You can see that it's come online there. What else can you do here? I'm not sure it's going to work for this microservice, but you can actually start a shell. I don't know if this is going to work. Let's just try it. No. So Authentic is set up for production. So it doesn't include a shell. It doesn't include bash or anything like that. So all that kind of stuff is removed, which is like an important thing to do in production for security. But if you were running Authentic on top of a version of Linux that had a shell, which you can easily do, you can easily change that, go and change that in your Docker file. Then you could shell into it here, and you could be typing commands inside the container. So it's not great for production, but it's really cool for experimentation and learning about Kubernetes and containers. And it's really useful debugging. Like if you hit a problem that you can't debug locally, and you've got to shell into your container to find out what the hell's wrong with it, you know, it's possible to do that. Now I'm going to tear this down. I'm going to run Terraform. Actually, I'll just recall my previous command, but I'll run Terraform Destroy, and unfortunately I got to enter all the same details again. Now I'm running this manually. Again, I'm running this manually from my development computer. What you normally want to do is kind of put this in your continuous delivery pipeline. So, and all that is making invoking Terraform apply from within your deployment shell script. And then providing all the variables it needs on the command line, like I've done here. Instead of me typing all this, you should basically, for running it completely without a human in the loop, running it totally on automatic, you've got to do this all on the command line. And you can also use the auto approve command line option, which will mean you don't have to type yes at the end. But let me just clean up after myself here. Make sure I get all these right. So it's again looking at the Kubernetes cluster, looking at what has been done and figuring out what it needs to do. So it's given us a plan again. In this case, the plan is basically to delete everything that I've just created. So I'm going to hit yes. So that's coming down now. That's fine. I think we're done with that. So that is my demo done. I've shown you how to deploy a microservice that we built earlier using the continuous delivery pipeline for that microservice, and then we deployed it manually to Kubernetes. The only thing left to do is to basically put those commands in your automated continuous delivery pipeline. Now, to end this talk, I just want to highlight the differences between a monolith and microservices. A monolith is just one large process. Microservices are many, many small processes. You can see both of these on the diagram here. There's a spectrum of possibilities between monolith and microservices. On the left, the extreme left is the monolith. On the extreme right are the microservices. You know, there are many valid positions on this spectrum where you could position yourself. So it's not just a choice between monolith and microservices. Your application can be composed of services of whatever size you want and whatever quantity you want. You know, there are of course real benefits of steering yourself towards the right-hand side of this spectrum, you know, steering yourself towards microservices, but you have to be smart and choose a position that works for you, your project, and your company. So there's no one right approach to software development. Microservices are a really important part of our toolkit, but they can live there alongside other valid techniques, you know. It doesn't have to be all about microservices, even though they have a lot to offer. And we have a spectrum of possibilities here that we could choose from. Well, that's it for this series of talks. There's a couple of takeaways that I would like you to remember. Firstly is to go to production early. And it's easiest to go to production while your application is still small. And getting to production is where you need your application to be in front of customers or indeed potential customers. And that is where you want to get it so you can get feedback. And you should do that as early as possible in the product lifecycle. Continuous delivery, it's not very complicated. You can think of it as just a shell script running in the cloud. Kubernetes is a really awesome platform for microservices, and you can bank on it becoming more and more important in the future. So please keep your eye on that. And you know, we have a choice to make when building applications, but it's not a choice about, whether we build monolith or microservices. There's that spectrum that I showed you. So there's a lot of possibilities, and we don't necessarily have to go to either extreme. Microservices have a lot to offer, but it's perfectly okay to choose, whatever number and whatever combination of size of services that's going to work for you. So here's a link to my book, Bootstrapping Microservices. If you need help with the practical aspects of building microservices applications, this is the book for you. I've got one copy of the ebook to give away today, but for everyone else, there's a 35% discount code on screen. Thanks so much for listening. Please hang around for a chance at the free book. I'm going to take it from the people that are in the talk right now. And please just give me a moment to do a random giveaway, and then I'll answer some questions. So I'm gonna pick a random number, but we've got 6 people that can get this, because I've already given one of them away. So person number 4, I'm going to count down. Spencer, you are the winner. Congratulations. I'm going to be giving you a free copy of my book. Let me just open up. I'll just open up a chat with you, and I'll give you what you need right now. Let me just open up. If I can just go through my personal page here to find the link to my book. Ah, that's not good. The Manning website is down. You'll have to look at that again later. Okay, so Spencer, I've given you a code for the book. You can use that link to buy the book and enter the code, and you will get it for free. If you have any problems redeeming the book, please email me on ashley@codecapers.com.au, which you can see in the slides here. I'm gonna put these slides later on meetup.com. So wherever you found this meetup in the first place, you can go back there and you can kind of find the slides, and find my contact details. So I've got one question in the chat from a little bit earlier. It says, how is it different from continuous deployment? So I assume here we're talking about the differences between continuous delivery and continuous deployment. I think they're fairly similar, and people will probably use those terms interchangeably. Continuous delivery is probably more general, where continuous delivery is kind of generally defined as the ability to deploy your application whenever you want. It basically means that you're always in a position to be able to deploy to production at any given time. Whether you choose to do so or not is another thing. And so continuous delivery is not necessarily about continuous deployment, but continuous deployment is you're in that situation where you are, continuously deploying it automatically whenever someone is pushing code changes. So, continuous deployment implies continuous delivery, but continuous delivery doesn't necessarily mean you have to automatically always, continuously be deploying your application. So, I mean, the differences between the two are really just like semantic. If you think it sounds a bit confusing, it's just because it's really just words. Like they're both pretty much the same. But there's a book called Continuous Delivery, and if you really want to drill down on the differences, I really recommend reading that book. I've got another question, but before I come to that, I just want to say as well that just because you're doing continuous deployment, let me just organize this so you can see me. Just because you're doing continuous deployment, it doesn't mean that you kind of need to roll out every code change, right? So typically what you'd have is multiple branches in your Git repository. So you might have the main branch, you might have the test branch, and you might have the production branch. That's typically what I use on my production projects. And so developers are working in the main development branch. Whenever they push their code, it goes to the development cluster automatically. So that's not customer facing. That's just a place where developers can kind of test their code in a production-like environment. And then when we want to do a release, which we can do as frequently as we want, or we could do it daily, or we could do it weekly. I mean, it's totally up to you, the frequency of your deployments. But then to do a release, we basically merge from the development branch to the testing branch. And what that does is it causes an automatic deployment to the test cluster. And that means then, we're not accepting continuous changes from dev into that cluster. Basically, what we want to do is we want to kind of test it. We want to stabilize it, make sure there's no bugs. We can fix bugs or issues directly in the test branch and deploy them directly to the test cluster. Once we're happy that that's all working, then we can merge from test to the production branch, and pushing that branch is what actually triggers the production deployment. Now, each of these types of deployment, they all have their own automated testing and their own, other checks and balances, whatever checks and balances you need that can be automated. We've accounted for like a manual testing phase. So, this is a fairly sophisticated deployment structure. You don't need to do that to get started. You could just start simply with one branch that deploys to production. And, once you start getting customers, or you start growing your development team, you're going to run into problems like, developers, accidentally putting a problem in front of a customer. And that's when you want to separate out to having like a separate test branch so that you can test your code thoroughly, like in a production-like environment, before it goes to the actual, customer-facing production environment. So hopefully that makes a bit of sense there. That just because we can automate it doesn't mean we have to. So someone else says, are you using blue-green deployment to do testing as a backup when you make code changes? No. So I actually use blue-green deployment infrequently. So like I said, I have. Typically what I'll have in a production project is a dev cluster, a test cluster. They're quite small, I want to run them cheaply, so they're quite small. Normally I run them on one VM. So, sometimes I have to run them on more than that for bigger applications. But, one VM, when it's only your developers and testers using it, that's what you want to start with. So I have a dev cluster, a test cluster, and then I have a blue cluster and a green cluster. And so the blue cluster and the green cluster are there really just for doing infrastructure changes. So sometimes you might want to experiment by replicating microservices and make sure they work, or like doing work on one of your servers, like your RabbitMQ server, or you want to kind of add another node, or like anything you want to do that involves changing the infrastructure that could potentially break it. It might not break it. It might all come off good, but mistakes happen, obviously. So any risky infrastructure changes, you want to do them in the alternate cluster, and then you flip the blue-green labels. Oh no, sorry, you flip the DNS between the two labels, and so then your customers can be on the new cluster, and then you can be doing all your risky changes and the other. But this is not a way to kind of test code for microservices. So for that, basically what I'm doing is that the initial stop for testing obviously is on your development computer, is do the testing that you can do on your development PC. You should have a testing regime that's geared up to allow that effect, because that's the way to be efficient and effective as a developer and do good testing, is on your development PC. But that by itself is not enough, because once you deploy to production, other problems can arise that you couldn't have tested for on a single laptop or development PC. So that's when you want to push to your development cluster, and that allows the developers then on your team to basically test what they're doing in a separate cluster, and then merging to the test branch and pushing that, which goes out to the test cluster. So that's where then you're testing, you're doing your final tests before you do a release, and then you're merging to prod. And so when you push your prod branch, that's basically being rolled out directly to whatever your current customer-facing production environment is. And so you're not using blue-green deployment to. You could theoretically you can use blue-green deployment within your cluster, right? I don't do that. I don't find that it's necessary. with Kubernetes, because Kubernetes already kind of does something like that for you anyway. So when you deploy an updated microservice to Kubernetes, in production, what you want to have is 3 replicas of that microservice, and it's going to do like a phased rollout. So it's going to roll out like one instance of the updated microservice, and it's going to push some traffic to that. And if the HTTP requests are successful, so this kind of health checking is built into Kubernetes. And you can augment your microservice to work better with this. If that new updated microservice fails, then it's automatically going to roll it back to the previous version. But if the tests against that microservice succeed, Kubernetes is automatically going to roll out all the replicas to that new updated version. So I'm constantly and safely rolling out new code to my current customer-facing cluster. Hope that helps and makes a bit of sense. Are there any tools which help? Oh, sorry, just going back to the other question. Troy says, I didn't realize it could do all of that. But yeah, I mean, as developers, like we have these fairly large toolkits. Like, yeah, I mean, there's tools out there that you probably don't know about. But you know, full toolkits of techniques, software, you know, practices that we can do, technologies that we can use, frameworks that we can use. Well, that's what development is all about, is like sort of assembling your toolkit. And you can use it any way you want. Like the way that I'm telling you throughout all this is just my recipes. You know, a lot of these recipes that I'm using are fairly common in the industry, but it's not the way that everyone does it. So, and you know, your problems, the problems you're solving in your company or your project could be very difficult to the problems that I'm trying to solve. So you're necessarily going to want to consider all the options and figure out what works best for you. And you know, I'm telling you about the things that have worked best for me in production, and everything I tell you as well, I've tried in production. So that's why I'm vouching for it. But there are plenty of other tools and techniques that I have not tried that could be good as well. So keep your eyes open, keep your minds open. I've got another question here. Are there any tools which help you with blue-green deployment, or is it a manual process changing DNS entries? Well, like the kind of the blue-green deployment that I told you about that happens within the Kubernetes cluster, that's actually called a rolling update. So if you want to learn more about that, Google Kubernetes rolling update. It's a bit like blue-green. It's a bit like that. It's just not called that because there's so many different techniques like this, right? There's so many different techniques like this that have different names. You know, slightly different implementations or something like that. So Kubernetes can do some of that stuff for you, and it's got really good support for managing the health of your microservices. You know, not rolling them out if they're failing. You know, letting you know if there's problems. Now, the blue-green deployment that I'm talking about at the cluster level, that is literally me just changing the DNS. So, you know, when I'm happy, or when testers come back and say that they're happy with the, you know, what's happening in the alternate cluster, then I swap from blue to green or green to blue, you know, depending on which way we're going. But that is me literally going into a DNS record and changing the IP address that it's pointing to. Now, there are probably tools that can help you with that. I don't actually know of any off the top of my head. It's pretty simple to do manually, and it's fairly infrequent. So I don't worry. I haven't worried too much about automating that because I don't do it very often. It's those kind of infrastructure changes that I do that are supported by blue-green deployment are fairly infrequent. So it's not something I have a problem doing manually. Cool. I think we're about done. Does anyone else have any other questions? I'll just put up the link to the book and the discount code again for a few minutes. Hang on, let me get it back. Does anyone have any other questions before I wrap up? Just make sure I haven't missed any early ones. Well, thanks so much, everyone, for listening. It's been a real pleasure to talk to you all again. If you want to spread the word, please show people my my YouTube account. So you'll be able to find this talk there in the future. You can find all the parts of this talk. There's heaps of other good stuff there as well. Also, please spread the good word about my book. Thanks so much for listening. Been great to, my privilege really to be able to talk to you today. Thank you.